So continuing our study of statistics, we're going to move into section 9.2 about surveys, experiments, and observational studies. Section 9.1 was all about trying to create a good sample that was representative of the population. Now we're going to focus on, once we have that good representative sample, how can we make sure we're collecting good, valid data from that sample? And there are three different ways we can collect data. We can do a survey, we can run an experiment, or we can use what's called an observational study. To give you a sense of what these three things are, we're going to take a look at the example on the top of page 10. Mrs. Sanker wants to study the effects of students using their cell phones during their study halls. And we're going to see three different ways that she can conduct this study. In part A, Mrs. Sanker obtains a simple random sample of students and gives them an anonymous survey, asking a series of questions related to if students feel like their cell phones are a distraction or if they help students get work done during study hall. This is an example of what we call a sample survey. We're surveying a sample. I know you know what a survey is, but I do want to give a definition for a survey. It's just going to be a questionnaire to collect responses. A sample survey is just a questionnaire to collect responses. The goal is just to collect data. We can't really do more than that. We're just collecting data here. And actually, because we're just collecting data here, we're not going to reach a conclusion. We're just going to be left with some data, and then it's going to be left for other things to look at that data and analyze it. This is a sample survey. Please remember, as we go through these notes, pause the videos if it's going too fast for you so you can write things down. But I do want to keep moving. Please make sure you're pausing things when you need to. In letter B, Mrs. Sanker asks Mrs. Ebern to note which students in her A block study hall use their cell phones and which don't. She then has Mrs. Ebern note how productive each student was during that study hall in an attempt to see if there's a correlation between cell phone use and productivity. This is an example of what we call an observational study. In an observational study, we're observing individuals and collecting data, but in our observations, we are not influencing the responses. An observational study observes individuals and collects data, but doesn't influence the responses. And what I mean by that in this example is Mrs. Ebern's not telling certain people you can use your phone and you can't use your phone and then looks at the responses. Instead, she's just observing what they would do normally and collecting data based on that. Again, our goal here is to collect data. And we actually can reach a conclusion based on this. Our conclusion is just going to be what we call a correlation, a connection between variables. Our conclusion is going to be a connection between the variables, also called a correlation. We're going to be using that word a little bit more later. All it says is that there's a relationship between the variables. There's a relationship between cell phone use and how productive people are in study hall. What's important, though, is that if we run an observational study, it can determine a connection between things, but not cause and effect. We can't necessarily say that just because we see a connection between these things, cell phone use causes people to be less productive or more productive. And the reason for that is the students are basically choosing their own groups of what they're in. The group that's using their cell phone or the group that's not using their cell phone. Well, other things might affect if they decide to use a cell phone or not. Maybe the more studious students are the ones who choose not to use their cell phones, which is why they're going to be more productive. Not because of the cell phones, but because they're more studious students in general. We can see a relationship, but we can't determine that one thing causes something else. As opposed to what we're going to see in our third type of study. Mrs. St. Kerr asks Mr. Wixer to randomly divide the students in his G-block study hall into two groups, groups A and B. Group A is prohibited from using their cell phones for any purpose during study hall. Group B is allowed to use their cell phones. She then has me note how productive each student was during that study hall in an attempt to see if cell phone usage causes students to be more or less productive. This is an example of an experiment. And in an experiment, we deliberately do something to some individuals in order to observe their responses. We deliberately do something to some individuals in order to observe their responses. Our goal here is to compare groups. One group was not allowed to use their cell phone, one group was, and I want to see if there's a difference between the groups. So my goal here is to compare groups. And because I assigned those two groups totally random, and I was the one assigning them rather than the students picking what groups they're going to be in, here, and the only thing that was the difference between the groups was if they were using their cell phone and if they weren't, my conclusion is a cause and effect conclusion. I can determine if cell phone usage causes students to be more or less productive. This is called causation. If we're running an observational study, the best we can do is conclude a correlation that two things are connected. If we're running an experiment, though, we can conclude causation, that one thing causes something else. What are the similarities and differences between the three alternatives? Do any display clear advantages or disadvantages? Well, all three different methods are collecting data, but the first two methods are really just sort of collecting data. We can't actually conclude that one thing causes something else. In our third method, the experiment, we can actually conclude that one thing causes something else to happen. Disadvantage of an experiment, though, is it's a little more involved to do than just an observational study. For this experiment, you would need buy-in from the students to be, in a study hall, not using their phone or using their phone based on what the teacher says rather than what they choose to do. An observational study is a little bit easier because you're just watching what's happening. Survey is even easier than that because you don't even have to watch people and record data. You're just going to give them a questionnaire and have them respond to a couple questions. So what we're going to do for the rest of this section is just go into more details of surveys, observational studies, and experiments. And we'll end with looking at a couple scenarios and try to determine which method is being used and what sorts of conclusions we can draw from it. On the next page, we're going to focus on surveys. Last time, when we were talking about creating random samples, or just samples in general, we were concerned about making sure there was no bias in those samples. And we saw that our simple random sample was the best way to do that. That's one way, though, that we can have bias when we're doing a survey. We can have bias in the way a sample is collected. And that's what we looked at last time. That's what we did in section 9.1. We saw that if we go to the library and want opinions on books or something, we'll get a different response than if we just go to the cafeteria or something like that. So we need to make sure that we're getting a good random sample. We're not going to spend more time on that. Instead, we're going to focus on making sure we don't have bias when we're doing a survey because our questions are poorly written. So the other way we could have bias is if our questions are poorly written. So we need to make sure our questions are written in a way where there is no bias. There are three ways we're going to focus on. First of all, the wording might encourage the responder to answer in a particular way. The wording might encourage the responder to answer in a particular way. For example, isn't summer your favorite season? The way this is being asked, it seems like they're trying to sway the responder to say, well, sure, yeah, summer's my favorite season. Maybe an unbiased way of asking this would be, what season is your favorite? Another way the wording might encourage the responder to answer in a particular way might be to make one thing sound better than something else. Would you rather eat this delicious slice of chocolate cake or just have a boring apple for dessert? Obviously, they're trying to make the cake sound better there. Another way that a question could be biased is the question might be what we say too sensitive to respond truthfully. The question might be too sensitive to respond truthfully. For example, let's say you go to the doctor and they ask you, do you eat healthy? Even if you don't, I don't know too many people who are going to say to their doctor, oh no, I just eat junk food all day long, every day. If the doctor instead gave all his patients an anonymous survey where there was no way that the doctor would connect your response to you, then I think you'd be able to answer a little bit more honestly. But if they're asking you directly, do you eat healthy? You might not respond truthfully and tell the doctor to his face that no, you really don't. The other way that a question could be biased is the question might not give enough information. The question might not give enough information. For example, what do you think of the new grading policy for this e-learning work? What do you think of the new grading policy for this e-learning work? And I think that a very natural thing to ask is, well, what is this new policy? If you don't actually know what that new policy is, by the way, I don't think there's a new policy unless there's something that I haven't been told yet. If you don't know what the policy is, though, you can't answer that question. So we need to make sure that our wording isn't trying to encourage the responder to answer in a particular way. We need to make sure that the question isn't being asked in a way that you might feel uncomfortable answering it truthfully. And we need to make sure that the question gives enough information. On the bottom of the page, we have a question being asked, and we need to, with some bias, and we need to rewrite the question in a way where there's no bias. Letter A, a reporter asks parents, do you agree with the school board's proposal for new technology in our schools? Well, I've got a whole bunch of issues with this. First of all, one way there's bias. Do you agree? They're steering them towards agree. Another issue is, well, what exactly is the proposal for new technology? Not clear enough. Not enough information. And actually, I think that the fact that a reporter is asking parents might make it a little bit uncomfortable to respond, and they might not respond truthfully, thinking that their name might end up in the paper or something on this. So actually, we've got all of our issues there. Too sensitive the way it's being asked. To fix this, maybe give an anonymous survey. Asking, what do you think about the school board's proposal for every student to get a Chromebook? What do you think about the school board's proposal for every student to get a Chromebook? Off the screen. For every student to get a Chromebook. Letter B. A dentist asks patients, do you brush your teeth at least twice per day and floss every day? Well, I mean, they're going to figure it out sooner or later once you open your mouth. But if they're just asking the patient's probably going to feel a little uncomfortable telling the dentist, no, I never brush my teeth. If they want to collect good data, they're going to ask this in a confidential way. Confidential, and more importantly, anonymous way. Give an anonymous survey. So this is our information on surveys. Remember, if you haven't had time to write everything down, make sure you pause the video and copy down this information. And now we're going to move on to observational studies. In an observational study, we are looking at a sample and we're collecting data from that sample, and then we're trying to use that sample to make generalizations about the population as a whole. Remember that our sample just consists of the individuals who we're collecting data from, consists of the individuals, either people or objects, we are collecting data from. And we're trying to use that data to make some generalizations about the entire population. Our population of interest, all individuals, people or objects. We want to generalize that's not spelled right. Generalize our data too. This will make a little bit more sense when we start looking at some concrete examples, which we'll do on the next page. But our population of interest, all the individuals, we want to try to generalize our data to. More with that in a moment. As for experiments, we're going to focus on these things called controlled experiments, and I'm pretty sure you've talked about these in science class over the years. In a controlled experiment, two groups are studied under identical conditions with the exception of only one variable. Two groups are studied under identical conditions with the exception of only one variable. Two groups are studied under identical conditions with the exception of only one variable. Going back to that cell phone example, that was a controlled experiment, the one that I was running, because I randomly split people into two different groups. It's not like I put all the girls in group A and all the boys in group B and said the girls could use their phones and the boys couldn't. The groups were random, they were mixed, and the only difference between the two groups were they allowed to use their phone or were they not allowed to use their phone? The control group is the group that's working under ordinary conditions. The group under ordinary conditions. As opposed to the treatment group, which is the group that gets something different. You might call this the experimental group in science. We're going to go with the treatment group. That's usually the statistics term for this. We're going to call this the group that receives the treatment. The something that's different, something that's out of the ordinary. Again, this will make a little more sense once we start looking at some specific examples on the next page. If you need more time, pause the video to finish copying. Otherwise, we're going on to page 14. We're going to look at a bunch of scenarios. We're going to determine what exactly it is. Is it a survey, an observational study, or an experiment? And we'll say why. If it's an observational study, we will identify the sample and the population of interest that we're trying to get information about. If it's an experiment, we'll identify the control and treatment groups. Then we'll figure out if we can determine causation or just correlation. Remember, causation means one thing causes something else. Correlation, the two things are just connected. And the way we can tell them apart, correlation is what we can figure out from an observational study. Causation is what we can figure out from an experiment. In letter A study investigated whether eating oatmeal for breakfast lowers your cholesterol. 30 people were selected for the study and asked if they normally eat oatmeal for breakfast or something else. Their cholesterol levels were tested, and it was shown that the people who ate oatmeal for breakfast had lower cholesterol. This is an example of an observational study. We're just watching what these people are doing normally. We're not controlling what they eat. We're watching what they do normally. We are not controlling what they eat. If we were saying you 15 must eat oatmeal for breakfast, you 15 must eat anything but oatmeal, then that would make it an experiment. Our sample, the 30 people in the study, and I think we're trying to generalize this population of interest. Really just to all people. I don't think I can really do much better than that. I can't be more specific than that. Based on the results, it showed that people who ate oatmeal for breakfast had lower cholesterol, but we can't determine that the oatmeal was causing the lower cholesterol because this was just an observational study. All we can determine is not causation, is correlation, that there's a connection. Perhaps some other factors influence whether you choose yourself to eat oatmeal or not. And maybe the people who are choosing to eat oatmeal in general have a healthier life, and that's why their cholesterol is lower, not because of the oatmeal, but because of other decisions that they make. Letter B. As your statistics project, you collect data by posting 5 questions on poster board around your classroom and recording how your classmates respond to them. Well, this is just a survey. We're just asking questions. Letter C. A professional sports team traded its best player. The local television station wanted to find out what the fans thought of the trade. At the beginning of the evening news program, they asked viewers to call one number if they favored the trade and a different number if they were opposed to the trade. At the end of the news program, they announced that 53.7% of callers favored the trade. This is still just a survey. We're just asking questions, actually just asking a question. And we're getting responses from people based on that. Nothing more involved. Letter D. The local Department of Transportation is responsible for maintaining lane and edge lines on its paved roads. There are 2 paint products on the market. Paint A, which is the type the town previously used, and Paint B, a new type of paint. 20 comparable stretches of road are identified. Paint A is randomly assigned to 10 of the stretches of road, and Paint B to the other 10. The department finds that Paint B lasts longer. This is an example of an experiment. because the Department of Transportation is randomly selecting 10 roads to get the regular paint, 10 roads to get the new paint. That's the only difference between the two roads. They're not focusing on heavy roads versus lighter traveled roads or anything like that. And then they're comparing what happens. The Department of Transportation is randomly picking which road gets which paint. So in an experiment, I have a control group and a treatment group. My control group, well, that's the group that gets what's normally done. Those are going to be the 10 roads painted with paint A, because that's the normal paint that's used. 10 roads painted with paint A. Our treatment group, the group that gets something different, well, those are the 10 roads painted with paint B. They found that paint B lasted longer. Well, because this was an experiment, we can actually conclude that yes, using paint B causes the paint to last longer. We can determine causation. The reason we can determine causation is simply because we ran an experiment versus an observational study. Observational studies conclude correlation. Experiments conclude causation. 3 more examples. Letter E. The National Highway Traffic Safety Administration conducts annual studies on driver seatbelt use at a random selection of roadways in each state in the U.S. To determine if seatbelt usage has increased, the data are analyzed over 2 successive years. Well, this is an observational study. They're not forcing people to wear a seatbelt or not. They're just observing what people are already doing. Our sample are the drivers who were selected at those random sites. And my population of interest, well, I'm trying to get information about all drivers in the U.S. When I'm done, I can conclude a correlation because it's an observational study. I can determine a connection between seatbelt use and driver safety and things like that, but I can't conclude a causation here. Letter F. People should brush their teeth at least twice a day for at least 2 to 3 minutes with each brushing. For a statistics project, you ask a random number of students at your school questions concerning their toothbrushing activities. Just a survey. We're just asking people questions, not collecting data in another way. One last scenario. A study determines whether taking aspirin regularly helps to prevent heart attacks. A large group of male physicians of comparable health were randomly assigned equally to taking an aspirin every second day or to taking a placebo, like a sugar pill. That's really just nothing. They have to give you something because if you don't have anything, well, how would you would certainly know that you're not getting the aspirin. If you take this placebo, you have no way of knowing is it the aspirin or is it not. After several years, the proportion of the study participants who had suffered heart attacks in each group was compared. Well, this is an experiment because the people running it are randomly assigning the male physicians to the 2 different groups. The participants are randomly selected for each group. and told what to take. In our control group, those are going to be the male physicians who took a placebo every other day, just the kind of normal, ordinary, no special treatment group. Those are the male physicians who took a placebo every other day. As opposed to the treatment group, which is made up of the male physicians who took an aspirin every other day. Based on the results, we can conclude a causation. Yes, the aspirin will decrease heart attacks or something like that. The reason I know that I can conclude a causation is simply because this was an experiment. For the homework, check out the website or the Google Classroom page. You're going to do a few of these. A few problems based on analyzing surveys and observational studies and experiments. If you have not enjoyed these last 2 days, this seemed a little bit, language heavy and more like an English class. We're back to calculations next time. So don't worry, there'll be numbers, there'll be formulas, and all of that when we move on in the next section. See you next class.